some of the parts of that. If I can be helpful to you here, I also want to sort of go over this. But remember, not really anything new here. So that's good news. We're just trying to solidify what we've done the last few days. And again, I just kind of asked nicely, how's that going for you? The vertical asymptote. It is one of the main ideas. If you're like, why is that a main idea? Because it has to do with a bad number. Bad numbers happen in the big bad denominator. So x equals 3 is a bad number because if I plug it in for x, I get a 0 in the denominator. And of course, that's going to make an asymptote, and that's one of the main ideas from this chapter. Some people have been asking, can you go over the horizontal asymptote? It's 3 rules. Now, they have to do with what's called the degree. The degree is the highest exponent in the numerator and denominator. Please make sure that when you look at the degree that you look at 2 and 1. And at this point, you should conclude that 2 is greater than 1. Now, if you're looking at your notes, that would say that there's no horizontal asymptote because the top is greater than the bottom. But you may also be concluding from yesterday's lesson that it's 1 greater. It's exactly 1 greater. That means that there's a slant. Now, since there's a slant, for better or worse, I have to divide. And so, again, there's sort of no way around it. I have to do this division. How's that going? You look at the first terms and you ask yourself, what do you multiply to get that term? I hope you would say that you multiply by 2x, because literally when you multiply, you get 2x squared. And you also get minus 6x. And remember, this is kind of that part that I always, with caution, tell kids subtract, but that means change the sign. That's at least the way I like to think of it. So we're going to change the sign, and now it's actually negative x plus 6x. Negative x plus 6x is 5x. If you're catching on to this, you'll realize that this is the last thing I need to think about. That is, x times what is 5x? It's 5, but the reason that's the last thing I have to think about is because as soon as I get y equals mx plus b, as soon as I get mx plus b, I'm done. That's my slant. If you don't like stopping sort of mid-route, you can continue the problem. You're basically just going to get a remainder. And we said that you can ignore the remainder, but maybe you say, I'm good, I'll stop right here because that's mx plus b. If you watched my 6-minute extra video clip yesterday, you might have noticed that I just kind of crossed off x's. I just kind of erased them. Because if you plug a 0 in for x, if I plug a 0 in for these x's, it's just kind of get rid of everything except the negative 3 and negative 3. And maybe just mentally you say, hey, negative 3 over negative 3 is 1. Well, 0, 1. Because you plugged in 0 and you got 1. So the y-intercept sometimes, hopefully most of the time, is pretty easy to find. The x-intercept, maybe not quite so easy. The x-intercept is when the equation is equal to 0, because you're really plugging a 0 in for y. Now, when the equation is equal to 0, the denominator can multiply over there and just kind of wipe out. But eventually, you say, I gotcha. It's just the numerator that's equaling 0. It's just the numerator that basically I have to think about. Now, nobody really said anything on the homework, but maybe it requires the quadratic formula, like number 2. Or maybe I can factor it. Sometimes people say, how do you know? Well, most of the time it's experience. Maybe the teacher gives you a hint. Listen, it can be factored. And if you do a little guessing and checking, you can come up with 3 and 1. Now, 3 and 1 have to multiply to be negative 3, so we have to make one of them negative. It turns out that you want the 3 to be negative. through a little guessing and checking. Or you can use a British method, or you can use the quadratic formula. But the whole point is that we have to get these x-intercepts, which actually end up being like the opposites or the roots of these factors. So 3/2 and -1, 0. Now this problem's a little beefy. I thought we'd do one a little more involved if we're going to do it together. But remember, hi, Miss Karen.
Hi, Mr. Cuddy here?
He is back here in near the post. Now, listen, like I said, the problem's a little bit involved, but the whole reason we did all this stuff in yellow is so we could graph it. So before you get Desmos out, you should be graphing your vertical asymptote. You should be graphing your slant asymptote. Now, listen, a slant asymptote was a new idea yesterday, but it's a slanted line. It's got a y-intercept of 5. It's got a slope of 2. You know, you should draw a line that has a y-intercept of 5 and a slope of 2. Nobody's measuring the slope, so, you know, just basically draw a diagonal line. But if it had a negative slope, then I hope you would draw it the other way, etc. So we got some asymptotes. How about all these intercepts? Okay, there's going to be a time where you realize that these intercepts, okay, now these intercepts, I might not have them perfectly to scale, I will confess, but these intercepts, oops, I've also got them backwards. Those 3 polka dots are to help us draw the graph. So put them on the graph, okay? But then go to Desmos and take a look. Just notice the order that I'm following here. I am not using Desmos until the end. But you do want to use Desmos, okay? You do want to make sure that you take some time and you graph this. What is it? X minus 3. I encourage you to graph it on your own, but if you're looking up here, that's fine right now also, because we have a little problem. The problem is that this is not the entire picture. This is not the entire graph. You say it isn't. Again, as you try to gain more experience, you should feel like that there has to be another branch. There has to be another branch because there's another side to the asymptotes. So you need to get a bigger view. You need to get in the hot air balloon and climb up a little bit. Now, I'm pulling back. I'm doing a little like zoom out. And then I can see the fields and the ponds, and I can see for miles and miles, and I can see this branch. I'm talking about the branch up here has to be also part of our graph. Now, the branch right here is probably not a big surprise because we already had all these polka dots, but it's this one up here that we need to kind of go look for. The problem is a little harder because I thought, let's look at one that is more involved if we're going to do it together. But I'm trying to get you guys to grow every day, get a little closer to understanding. So there's some practice problems. Will you practice them? Will you keep trying to grow? There's a mini check. Like I said, if you know what you're doing, 10 minutes should be more than enough.